Hello, my name is Hannah Mechtenberg, and I'm a graduate student in psychology at the University of Connecticut. Here I am presenting a study that looked at how monetary reward influenced talker-specific phonetic recalibration. Talkers differ in their production of speech sounds, and listeners can learn these idiosyncratic productions over time in a process called phonetic recalibration. One of the strongest guides for this type of learning is lexical knowledge, or our knowledge of what are words and what are not words. Say you are listening to two different talkers speak. One talker, let's call her Jane, produces her S sounds more like esh. So episode would sound more like episode. You correctly interpret the ambiguous sound as an S because episode is a word and episode is not. Now, the other talker, named Austin, has the opposite bias. He produces his esh sounds more like S, resulting in pressure sounding more like presser. Over time, you learn the idiosyncratic ways each of these talkers produce their speech sounds such that in subsequent encounters, you will interpret ambiguous sounds such as a mix between sign and shine in line with the talker's bias. So for Jane, you would perceive an ambiguous word between sign and shine as sounding more like sign, while for Austin, you would perceive it as sounding more like shine. Previous work from our group showed that listeners can learn the idiosyncratic productions from multiple talkers when the exposure to each talker is intermixed, as occurs in ecological conditions. Knowing this, we asked if multi-talker phonetic recalibration might look different if one talker has a greater perceived value than the other, so your advisor compared to your barista. To test this question, we introduced the possibility of a small monetary reward for each trial during exposure. We were interested in whether this monetary reward would bias listener attention towards the talker with the higher value, manifested in a larger learning effect for the higher value talker compared to the low value talker. We used a lexically guided perceptual learning paradigm, which is designed to induce a talker-specific S-esh boundary shift. First, talkers completed the exposure task in which trials for both talkers were randomly intermixed. During this task, listeners heard a word and then were asked to indicate whether the talker was male or female. Then there was the possibility of reward and feedback or not. We implemented a probabilistic reward schedule such that listeners did not receive a reward on every trial. The idea was that listeners would, over time, learn which talker was rewarded more than the other. We used two different reward schedules, 3-1 and a narrower 5-3 schedule. We also included a control condition in which we replaced the reward indicator for squares to control for saliency effects. After exposure, listeners categorized stimuli from a sign-shine continuum for each talker with the order of the talkers counterbalanced. We ran a total of 5 experiments, each with 64 participants. Now the results from the 5 studies. We looked for 2 primary effects, a main effect of bias, which indicates that there was phonetic recalibration for each talker. The other result was whether phonetic recalibration was modulated by the value of the talker. First, the results from our control condition. We found evidence for phonetic recalibration, but critically, learning was not modulated by which talker had a higher incidence of seeing a neutral shape. Learning was statistically equal for all conditions. Now onto the rewarded studies, which was a bit more mixed. We initially, in the first attempt with a 3-1 schedule, found evidence for phonetic recalibration that was modulated by rewarded talker, exactly what we predicted. However, in subsequent replications, we saw no evidence of learning, either as a main effect or as modulated by rewarded talker. We suspect that the first attempt was not a true effect. In the reward 5-3 study, we saw evidence of phonetic recalibration, but no interaction with rewarded talker. So where does this leave us? Our primary goal is to understand how reward processing interacts with perceptual recalibration for multiple talkers. Despite our first attempt, the first 3-1 study introducing monetary reward appears to disrupt learning, or at least makes the phonetic recalibration effect more fragile. We have run additional studies investigating this effect that we did not report here, and no matter the cover task we use or when reward was introduced, phonetic recalibration is disrupted. This is early into our investigation, so we don't have any conclusive ideas for why monetary reward appears to interfere with learning. Maybe the effect is attentional. Processing monetary reward pulls necessary resources away from processing the phonetic ambiguities. Or maybe there's a more direct effect of reward as competing with dopamine mediated prediction error signals that are essential for phonetic recalibration. We hope to gain clarity in future experiments. Thank you.